All right, everybody, welcome back. Thank you for taking the time to watch this video. I hope you find it worthwhile. Today we're going to be talking about standard P6A, which is rational expressions. This will be a 3-day standard, so you will find three kind of sections, A, B, and C, that will be relating to these rational expressions. Before we begin on working on simplifying rational expressions, let's just go through and do a warm-up. I know we got a lot of material that we've been covering the last few days, and I do want to make sure that you're prepared for that upcoming test that we have. So looking at this problem, right, we have, this is a rationalizing the denominator problem, right? We don't want to have any radicals in the bottom, so we got to find a way to get rid of that. Remember, whenever you have this plus or minus, you got to remember to multiply by the conjugate. So you would multiply this by 4 minus the square root of 5, and whatever you do to the bottom, you also got to do it to the top. Now, doing that, remember, these are quantities, right? So we got to be careful, and we got to distribute when we do this. 2 times 4 is going to give us an 8. 2 times a negative square root of 5 would be minus 2 square roots of 5. Let's change colors on you. Negative square roots of 3 times 4 would be a minus 4 square root of 3. And a negative square root of 3 times a negative square root of 5 will be a positive square root of 15. Jump into the bottom now. 4 times 4 will be 16. 4 times a negative square root of 5 will be a minus 4 square roots of 5. Let's change colors again. Positive square root of 5 times 4 will be 4 square roots of 5. And square root of 5 times negative square root of 5 is a minus square root of 25. Now, if we did that all correct, one thing we should be sure of is that our radical in the bottom is going to disappear. These two, of course, cancel out. The square root of 25 is just 5, so that's a minus 5. So 16 take away 5 leaves us with 11 on the bottom. Up top is going to look a little bit more complicated. Maybe it looks like actually the top could be as simple as it gets. 8 minus 2 square roots of 5 minus 4 square roots of 3 plus the square root of 15 is actually a good answer. That's as far as we can go. Now, I just want you to think about that for a minute. Remember, we can't put these on the same pile if they don't have the same radical. None of those have the same square root, so none of those can get combined. The last thing you want to think about is, are all my radicals simplified? 5 can't get smaller, 3 can't get smaller, 15 is just 3 times 5, and neither one of those can get smaller, no pairs, so we're done. Great. Let's talk about rational expressions. Rational expressions really are just dealing with fractions, in particularly like uglier fractions than what we're used to dealing with. Now, in fact, while this looks like it's something that's complicated to do, at first here, as long as everything is multiplied together, this is a really, really easy process. And as you can see in this problem, everything is multiplied together. And here's what that allows us to do. First off, when we have our 16 and our 20 there, we can reduce these just like we would a normal fraction. So 4 obviously goes into both. 4 goes into 16 4 times. 4 goes into 20 5 times. So that's going to now be a 4 and a 5. Now, technically, when we are dealing with powers, we have two things that have the same base and different exponents. We take the top exponent and we subtract the bottom exponent. That is the rule. The problem with that is that's going to give us negative exponents, and when we get negative exponents, then we got to start doing like this flipping around. Here's another way to tackle that same process. I like to think about it as like which one has more. If a to the 7th fought a to the 2nd, right, who would win? Well, obviously probably the one with more. And I always ask my kids, I say, well, how much more would they win by? They would win by 5. So this guy's going to get canceled off, and the 7 is just going to change to a 5 now. Let's try that again. So let's go with the B's. So who's going to win for the B's, the top or the bottom? Well, the top has more, so they're going to win, which means this one's going to disappear. How many are they going to win by? Well, they had one more person, so this is going to become a 1. Last but not least, C to the 4th and C to the 2nd. And who would win that one? Let's use a different color. How about this guy? Well, obviously the top would. Why? There's more. How many more are there? 2. So that's going to become C to the 2nd. Now, the nice thing about doing it this way and just kind of fighting them out where they are is the fact that you're never going to have to sit there and flip-flop them around because of negative exponents. So your final answer will just be 4 We don't have any a's up top anymore. We have 1b and c squared. And then on the bottom, we have 5a to the 5th. Something's up. 5a to the 5th. And that's it. Nothing else on the bottom. This is simplified, ladies and gentlemen. Now, I just want to refresh you on something, or just remind you of something. This was easy because of the fact at the very beginning here, everything was multiplied together. There were no pluses, there were no minuses anywhere. If you have pluses and minuses, you cannot cancel stuff out this way. So take advantage of it on the easy problems. On the harder ones, we got to be more careful. Here's another one for us. 120 and 25. We're going to start by just reducing the fraction. I know 5 is going to go into each. 5 goes into 25 5 times. 5 goes into 120 24 times, I believe. Better check that just in case. 120 divided by 5. You got it. Okay, so I'm going to reduce that fraction. That's done. Who's going to win for the x's? Better be the top. They have more, so this one's going to disappear. How many more did they have? Well, there's only 1 down here, so they had 2 more, so that's going to change to a 2. Who's going to win for the y's? Better be the bottom. We had 1 up top, 5 on the bottom, so there was really 4 more on the bottom, so that becomes a 4. And I am left with 24 x to the 2nd over 5 y to the 4th. That's all I had left. And we're done. Again, easy when they're all multiplied together. Again, these are all multiplied together. This minus is really just a negative, so we don't have to really focus too much on that. That's not what I mean when I say pluses or minuses. So dealing with 16 and 12, we know that 4 goes into each of them. So this is going to change to a minus 4. This is going to change to a 3. For the x's, this will cancel off, and we'll be left with only 3 in the bottom. For the y's, this will cancel off, and this will change to a 4. And last but not least, the z's. Now, z doesn't have any up top, so there's none to fight, so we just leave it. So our final answer will just be a negative 4. Y to the 4th. Over 3, x to the 3rd, z to the 4th. And we're done. Simple as that, ladies and gentlemen. It does not need to be more complicated as long as everything is being multiplied together. Now, I don't know if you can predict where we're headed, but in a minute here, everything's not going to be multiplied together anymore, and we're going to have to do some work. So we have laid out some steps here. These are your steps. A little too far. These are your steps to simplifying rational expressions. Step number 1, factor. Everything must be multiplication in the numerator and denominator. That's going to be the big secret today, folks, is when we factor, we turn our numerator, top of the fraction, and our denominator, the bottom of the fraction, into a multiplication problem. That's why factoring is so important, is because it can take an addition or subtraction, and it can make it into a multiplication problem. So we're going to take advantage of that as we go. Now, simplifying here is step number 2. Simplify any quantity that is exactly the same in the numerator and the denominator. That's kind of what we were doing when we were canceling stuff out above. And express any limitations on the domain. So here's our problem, or example problem for this. What you will notice is that we do have stuff that is being multiplied here. 2 is being multiplied by x, which is being multiplied by the quantity x minus 5, which is being multiplied by the quantity x plus 2. On the bottom, we have x squared, which is being multiplied by x plus 2. This one, they did the hard part for you, that hard part being factoring. If you have something that's already factored, ladies and gentlemen, then what you're allowed to do is this. You can cancel terms that are exactly the same. X plus 2, those are gone. And the reason we could do that is because of this multiplication here and here. This only works if everything is a multiplication. If there's a random plus sitting somewhere in there that is not contained within one of these sets of parentheses here, you cannot do this. So x plus 2's are going to cancel off. If I fought the x's out, I had 1 up top, so this guy's going to disappear, and this will change to a 1. Meaning, we will be left with 2 times x minus 5 over just x. Now, the last step of this said express limitations on the domain. Here is what we meant by that. Now, this is a fraction, ladies and gentlemen, and the big, super huge idea is that you can never divide by 0, right? In math, that does not fly. So looking at this problem, let's even go back to the original here for a second. We know what our answer is, but if you look at the original, there was 2 ways that you could have been dividing by 0. One of those ways, right, because this is just a term here, is if x would have been equal to a -2. And here's why. If x was equal to -2, this whole term would have ended up being equal to 0. And this whole term is being multiplied by this other term. So regardless of what this ended up being, anything times 0 would equal 0 on the bottom. So here's what we know. X cannot be allowed to be equal to -2. Because if it is, then we're dividing by 0, and we cannot do that. Now, the second place this could have been equal to 0 is this term. If that term would have somehow ended up being equal to 0, we have a problem. So you want to think to yourself, what number, when I square it, is equal to 0? And hopefully you know that that is, of course, 0. So we got to make sure x is never equal to 0. So we have 2 restrictions on our domain. X cannot be equal to 0, and x cannot be equal to a -2. Now in math, we say this a variety of different ways. Some ways we might say it is that, let's just leave it like this for now. If I find out that we do it differently in calculus and in the other pre-calcs, I'll come back and I'll change my thoughts on this. But let's leave at x cannot be equal to 0, x cannot be equal to a -2, and we're done. Now, when you are stating your limitations on the domain, right? The domain, of course, is your input values, your inputs. You always do that from the original function before anything is canceled out at all. Okay, so we always do it from that original. Let's practice this, but we're going to make you do the factor step now. So here's another problem for you. It says simplify, be sure to identify any restrictions on the domain. So factoring this, you can factor this however you want. I like my x method, -28 and 3. My numbers would be what, 7 and 4? And that must mean the 4 is negative. So I know that if I factor this, I would get x plus 7 and x minus 4. Now on the bottom of this thing, I'm going to get a -8 and a -2, which of course would be, let's say, a -4 and a +2. So I'll get an x minus 4 and an x plus 2. Here's what I would suggest to you, ladies and gentlemen. Step 1, factor. We have done that. Now, before you go any further, my suggestion is actually that we jump to step 3. That was supposed to be an arrow. And the reason for that is because you always need to express any restrictions on your domain before you actually cancel out terms. So right here, I know that x, we cannot allow x to be equal to 4, because 4 would make that term equal to 0, which in turn would make the whole bottom equal to 0. The thing about fractions is I don't care if the top is equal to 0. It's only if the bottom ends up being equal to 0 that we have an issue. That's why we're only worried about the denominator. The number that would make that term equal to 0 is if x was equal to a -2. So we're going to not allow that to be possible. Right? That's what we mean when we say restrict the domain. Now, coming a little bit further with this, I see that I have an x minus 4 on the top and then on the bottom. So those will cancel, and we'll be left with x plus 7 over x plus 2. And then we just want to make sure we very clearly state it by our answer that x can't equal 4 and x cannot equal a -2. Nice job. Let's look at another one. Here's another one for you. We're going to start again by factoring this thing. If you're good factoring, you probably look at this and you say, well, that has to be an x minus 6 and an x minus 1. Great. On the bottom here, you notice we only have two terms. Now, brain right now should be probably thinking difference of perfect squares. But if you look at it and you realize, well, 6 and x are not perfect squares of anything, then you have to go another route. And the other route you want to go is let's just pull out a greatest common factor. If I pull an x out of both of those terms, I would be left with just x times x minus 6. That's great. Now, again, before anything gets canceled, here's what I'm even going to do. Here's where I'm going to put my answer. Here is where I'm going to restrict my domain already. So looking at this, based on what I see, the number that would make that term equal to 0 would be if x was equal to 6. So I'm going to restrict my domain and say x cannot be equal to 6. The only way this term is equal to 0 is if x equals 0. So I'm going to restrict my domain and say x cannot be equal to 0. Once I've restricted my domain, then I'm allowed to come over here and to cancel. So looking at the top and the bottom, they both had an x minus 6. Those are going to disappear. So I will be left with x minus 1 over x. Biggest mistake people do right now, ladies and gentlemen, is they come over here and they think to themselves, let's cancel these x's. Absolutely not allowed. The reason for that is because of this minus sign. If that would have been a multiplication sign, we are allowed to do this. But when that is a minus sign, we cannot. Right? So you got to be very, very careful. Even if this had parentheses on it, that would be a great answer. But you cannot cancel those x's because of that minus sign. That is why we always need to make sure that we have multiplication all the way across the top and all the way across the bottom. And that's why we are factoring, right? Because factoring takes this problem with the multiplication or the additions and subtractions, and it allows it to be turned into a multiplication problem. Same thing on the bottom. The minus and the minus now become a multiplication problem, and that's why stuff is allowed to cancel. Let's talk about multiplying rational expressions. We've talked about simplifying. We're going to talk about multiplying and dividing. I don't think we get to adding today. That should be probably tomorrow. Here's how we multiply. So it says this is the exact same as simplifying, except you have more terms. You're going to push everything together, factor, and simplify. It says, note, you cannot separate any quantity, addition or subtraction, unless you factor first. Here's how we're going to handle this problem. Ladies and gentlemen, I always suggest factor immediately. So this 6 obviously is not able to be factored. Looking across at the bottom here, I have an x squared minus 9x plus 20. That will be able to be factored into an x minus 5 and an x minus 4. Looking at the top on my second one, I could pull out a 5 out of both of those terms, and I'd be left with an x minus 5. This is where I want to sit there and multiply. So essentially, you know that when we multiply fractions, we go straight across. So I'm just going to multiply kind of straight across and turn this into one, let's call it like a super fraction. 6 times the 5 would give us 30. X minus 5. Across the bottom here, I'm going to have 15 out front. X minus 5. X minus 4. Again, this is where, once it's all together, and it's all factored, this is where we get to restrict our domain. So, looking at the bottom, we know x cannot be equal to 4. So x cannot equal 4. Looking again at the bottom, the number that would make that term equal to 0, this is our zero product property, every time we restrict here, would be if x was equal to 5. Not allowed. This guy is a constant. Right? It's just 15. There's no x attached to it. That will never be equal to 0. We don't need to worry about it. Now we are at that fun part where we get to cancel and make it look a little pretty. The x minus 5s disappear really quick. This 30 and 15 can be reduced like a fraction. So 15 goes into 30 twice. So that's like 2 over 1. So up top, I am left with just 2. And on the bottom, I have 1 times x minus 4. And of course, you don't need to have the 1 there. You can have the 1. It doesn't matter one way or another. But I'm just going to leave it for now just so we can see it. We're done. That's it. Let's take a look at another one of those. Again, factoring first is our key to success here. So out of this first one, oh, this one's unique. Let's see if we notice something. So if I pull a 3x out of this, right, looking at it like that's a greatest common factor for me, I would be left with 1 minus, let's see, I'm blinking. Oh, 1 minus x. Oh, we're good, we're good. I thought we were going to have a difference of perfect squares where we'd have to kind of like flip around that by pulling a negative, but it doesn't appear that way. On the bottom here, we have x squared plus 4x minus 5. So that's going to be an x minus, or plus 5 and an x minus 1. Up top on the other one, we're going to get an x plus 5 and an x minus 4. And of course, 6x is not allowed to be factored at all. There's nothing we can do. So now we want to push these all together. And when I do that, I will have 3x times 1 minus x, x plus 5, x minus 4, an x plus 5, and an x minus 1. Now, looking at this, ladies and gentlemen, once you've factored, you've pushed it all together, now is when we restrict our domain. So based on this, x cannot be equal to a negative 5. Because negative 5 plus 5 equals a 0. Then on the bottom, if this term is 0, then 0 times whatever this term is will equal 0. That's a problem because we'll be dividing by 0 and that's not okay. Over here, the number that would make that term equal to 0 is 1. So we're going to make sure that never happens. X cannot be equal to 1. Now we get a cancel. Now if you're looking at this thing and you're saying, man, I only can really cancel this and this, but this and this I cannot cancel. And the reason is they're different. 1 minus x is definitely going to give us an answer that is different from x minus 1. The way we can actually combat that, because they're close, if you look at this top one and you think to yourself, well, if I just factored out a negative 1, right? So let's find some scrap paper here. 1 minus x. If I pull a negative 1 out of each of those terms, then I'd be left with a negative 1 plus x. And we know the order in which we add doesn't matter, so couldn't I just swap these two pieces around and say x minus 1 then? Right, so if I pull out a negative 1, then I can make that into an x minus 1. So let's do that. If we pull a negative 1 out, this will now become an x minus 1. How is that going to play a role? Well, negative 1 times a 3 will now make that into a negative 3. And in turn, this can cancel with that. So my final answer, what I'm left with here, will be a minus 3x. Looks like we also had an x minus 4. That was just hanging out there. And there was nothing else. There was nothing on the bottom to worry about. So we leave it like this. If you would have came over here and said, well, over 1, absolutely correct. Let's look at the last type. It's very similar to multiplying, but it's dividing. Now, in order to divide, it says, as with any fraction, you cannot divide. So instead, the way we divide fractions is actually by multiplying by the reciprocal. So in this problem, again, our directions are to simplify and make sure we restrict our domain. Here's how we are going to tackle this. We're going to first start by, you guessed it, factoring. If I factor the top up here, I would get an x minus 4 and an x plus 3. Factoring the bottom over here, if I pull a 4 out as my greatest common factor, I'd be left with an x plus 3. For my top, or the numerator of my second fraction, how about an x minus 4 and an x minus 2? And the bottom doesn't factor. Now, this is what we know, is that if I was left with x minus 4, x plus 3, and 4 times x plus 3, I could change this problem from a division problem into a multiplication problem if I simply flip this fraction, right? And, of course, multiply, right? Dividing is the same thing as multiplying by the reciprocal. So if I flip the second fraction, and it always has to be that second fraction that you're trying to divide by, we can turn this thing into a multiplying problem. And just like we saw in the last problems, multiplying is doable. It's easy. So now we get here. So let's push everything together. I would get 6 times x minus 4 times x plus 3. Across the bottom, I'd get 4 times x plus 3 times x minus 4 times x minus 2. Now, if you've noticed, we have not canceled out a single thing yet, and that's good because that canceling has to happen after we restrict our domain. So let's think about this. If I have an x minus 2, 2 would be the number that makes that equal to 0. So x is not allowed to be 2. If I had an x minus 4, 4 would be the number that would make that equal to 0. So x is not allowed to be 4. Last but not least, x plus 3. If I had an x plus 3 term, the number that would make that equal to 0 is if x was equal to a negative 3. So I'm going to ensure that x is never equal to one of those numbers that would cause us trouble by restricting the domain. Now, from here, we cancel any like terms, x minus 4, x minus 4. We got an x plus 3 and an x plus 3. 6 and 4 can be reduced. Let's make that into 3 over 2, making my final answer into 3. There's nothing else left up top, over 2 times x minus 2. And of course, x cannot equal negative 3, 2, and 4. Notice how I wrote those from least to greatest if you're going to write them all in one. Just helps the reader see what's going on. Nice job. Let's look at another one here. Again, this would be a great time. If you're like, man, I think I got this, pause that video and then do the problem on your own and let's see if we get the same answer. If you struggle along the way, then you can hit play again and you can see it worked out. Step 1, factor. Pull a 5 out of both of these, I'll get an x minus 4. Top can't be factored. Pull an x out of both of these, I'd get an x minus 2. Looking at the bottom, actually I think we factored this already, we get an x minus 4 and an x minus 2. I think that was the same we saw in this problem over here. From there, let's change this into a multiplication problem. The way that happens is you need to flip this fraction. The second one, always the second one. So I'm going to end up with 4x over 5 times x minus 4 times, I almost made a mistake. X minus 4 will now be on the top, as will x minus 2. And then on the bottom, I'm going to have an x times x minus 2. I like to formally push that together and make it look really pretty. That's just my own personal preference. Some people would try to start tackling the domain question from here. That's good too. If I push this together, I would have a 4x on top, along with an x minus 4 and an x minus 2. Across the bottom, I would have 5 times x would give me a 5x out front. Then I would get an x minus 4 and an x minus 2. Restricting my domain right now, x cannot be equal to 2. X cannot be equal to 4. And in this last term, the only way that term is equal to 0 is if x is equal to 0. So x can't be equal to 0. After we've restricted our domain, cancel away. Look at that. Even the x's cancel out. Kind of like we saw up top when they were just fighting out. They work the same way. And all you are left with is 4/5. Now, one thing that actually makes this a little unique is the fact that it's just 4/5 that is left. And there is no x even, but you do still need to state this as the domain because it's where it came from that we need to be aware of. Last problem we look at, here it is. Again, start by factoring. Pull out a 3, I get an x plus 4. Bottom won't be factored, nothing else to factor. That's fine. Change it to multiplication by flipping this fraction. I'll have a 3 times x plus 4. And then that is over 12x, of course. And then I will have a 48 x to the third over x plus 4, once that all got flipped. Now we will push everything together. 3 times 48, I need a calculator on that guy, maybe 144, I bet. 144. And I'm going to have x to the third on the outside. X plus 4. Worst thing you can do is actually distribute right now. You do not want to distribute. Across the bottom, 12x times x plus 4. Just want to check, make sure I actually flipped it. I did. From there, we restrict our domain. X cannot be equal to a negative 4. X cannot be equal to 0. Now we can cancel and reduce. Cancel, cancel. 1x on the bottom, 3 up top. Who wins? Top does by 2. So this becomes a 2. This guy disappears. 12 goes into 144 12 times. So this is going to disappear. This will become a 12. So my final answer will be 12. X to the second. With the fact that x cannot be equal to 4 in this situation, and x cannot be equal to 0. Great job. I hope you found this worthwhile. Again, just to review your skills quick, we started out just by simplifying the easiest of the easy. There's nothing to factor, just kind of cancel and reduce exponents. From there, we got stuff that was a little harder. We had a factor first, but we still use those same processes. Cancel stuff that's the same, but we added in this new expectation of restricting your domain, right? Express the limitations on the domain. Very important part. Moving on, we talked about how to multiply. That just goes straight across, make one super fraction. Dividing, we talked about how you can change a division to a multiplication by flipping the second fraction and then just multiplying across. Always remembering to restrict your domain. Thank you guys for taking the time to watch this video. I hope you found it beneficial. If you have any questions, please do not hesitate to reach out. Have a good day.